Welcome to our discussion for today, the Conic section part 1. This module will focus on circles. At the end of this module, I hope you would be able to define circles using its significant characteristics, determine the standard form of the equation of a circle through mathematical reasoning, demonstrate determination, patience, and critical thinking in understanding the key concepts on circles, solve situational problems involving circles through problem solving. In grade 10, your teacher have discussed the properties of circle, relations among chords, arcs, central angle, inscribed angle, and the tangent and secant lines. Remember those things, for these things or concepts are necessary as we discuss our lesson for today. Imagine yourself standing on the beach with your pet dog which kept on running around you. With just your arms swinging around so that your pet dog will not be entangled, you stand firmly. What figure will the paw prints on the beach form? Absolutely, you are correct. The paw prints will form a circle. Let us recall first the definition of a circle. A circle is defined as the set of all coplanar points such that the distance from a fixed point is constant. Can you still recall the term that we used to refer to that fixed point? Yes, you're correct. We call that fixed point the center of the circle. The circle divides the set of points on a plane into three sets. The first set are the points located on the circle itself. The second set are the points that are located inside the circle. The third set are the points that are located outside the circle. Let us go back to the situation that I have given you a while ago. Suppose the dog's leash is 2 meters long and another man and his cat was approaching. What would be the safest position so that the cat's and the dog's leashes will not be entangled? To answer the problem, we can graph the circle modeling the given situation. But before that, can you still recall the equation of the circle in standard form? In pre-calculus, we are going to use Desmos and GeoGebra. And in using those applications, we have to know the standard form of the equation of the circle. I'm glad you can still recall the equation of the circle in standard form. It is given by the square of x minus h plus the square of y minus k equals r squared, where h and k are the coordinates of the center and r is the length of the radius. In our problem, we assume that the center is at the origin, having coordinates 0, 0. Substituting the value of h and k to the standard form of the equation of the circle, we will have the square of x minus 0 plus the square of y minus 0 equals 2 squared. Simplifying further, we will have x squared plus y squared equals 4. In other words, when the center is at the origin, the standard form of the equation of the circle will become x squared plus y squared equals r squared. Going back to our problem, what is the safest position of the cat and the dog, such that the leashes will not be entangled? The safest position is that the cat should not enter the interior portion of the circle. Let us explore further the equation of the circle in standard form. Can we find the equation of the circle in standard form given only a point on the circle and the center of the circle? Let's see. Consider the given circle. Can you identify the center of the circle? Yes, you're correct. The center of the circle is at point C with coordinates 3, 1. In the illustration, you can also see 5 points. We have point A with coordinates 6, 5, points B with coordinates -2, 1, and points D, E, and F whose coordinates have not been identified yet. Can you identify the coordinates of these points? Yes, you are correct that F has coordinates 3, 6, point E has coordinates 7, -2, and point D has coordinates 3, -4. But can we determine the length of the radius of the circle? Yes, we can determine the length of the radius of the circle by merely counting the number of units from point B to point C. Counting that, we will have 5 units. Hence, we can say that the radius of the circle is 5 units. Is there any other way aside from counting? Yes, there is. We can use the distance formula. Getting the distance from C to B, we will have the distance of B to C is equal to the square root of the square of x squared minus x1 plus the square of y sub 2 minus y sub 1. Substituting the coordinates of the points B and C, we will have the square root of the square of 3 minus -2 plus the square of 1 minus 1. Simplifying further, we will find that the distance of C to B or B to C is equal to 5. Hence, we have center at 3, 1 and R equals 5. Are we now ready to to determine the equation of the circle in standard form? Yes. By substituting the length of the radius and the coordinates of the center to the standard form of the equation of the circle, we would be able to get the square of x minus 3 plus the square of y minus 1 equals 5 squared. Therefore, we can determine the equation of the circle in standard form if we have the coordinates of the center and a point on the circle. We can write the equation of the circle in standard form and in general form. The general form of the equation of the circle is given by ax squared plus ay squared plus dx plus ey plus f equals 0, where a is not equal to 0. Do you know the steps in writing the equation of the circle in general form? If not, let's have some example. Consider the equation the square of x minus 3 plus the square of y minus 1 equals 5 squared. May I suggest the following acronym: EARS in writing the equation of the circle in general form. E for expand, A for apply, R for rearrange, and S for simplify. The first step is to expand the binomials. Expanding the square of x minus 3, which means the quantity of x minus 3 times the quantity of x minus 3, we will have x squared minus 6x plus 9. Doing the same thing to the second binomial, the square of y minus 1, we will get y squared minus 2y plus 1. The second step is to apply appropriate property of equality. In this case, we have applied subtraction property of equality in order to transpose 25 to the left side. Thus, we will be getting negative 25. The third step is to rearrange the terms in such a way that the first group are the quadratic terms, x squared and y squared. The second group are the linear terms, negative 6x and negative 2y. And the last group comprises the constant terms 9, 1, and negative 25. Lastly, we simplify by combining similar terms. Simplifying 9 plus 1 minus 25, we will get negative 15. Therefore, the equation of the circle in general form is x squared plus y squared minus 6x minus 2y minus 15. Is that clear? I hope it is. Let me check if you really understand the steps in writing the equation of the circle in general form. Let's try this. Write the equation both in standard and general form of a circle having r equals 2 and center at 1, negative 1. You may pause the video while working on it. The standard form of the given circle is the square of x minus 1 plus the square of y plus 1 equals 2 squared, or the square of x minus 1 plus the square of y plus 1 equals 4. While the general form of the equation of the circle is x squared plus y squared minus 2x plus 2y minus 2 equals 0. Congratulations! Job well done. What about if you're asked to write the equation in standard form given the equation in general form? Do you know the steps in writing the equation in standard form from general form? If you used acronym EARS in writing the equation in general form, we will use the acronym DEF. D for determine, E for exclude, A for add, and F for factor out. Consider x squared plus y squared minus 6x minus 2y minus 15 equals 0. The first step is to determine the terms with the same variable and group them using parentheses. Make sure that the numerical coefficient of the quadratic term is 1. The first group are the terms having the literal coefficient x. The second group are the terms having the literal coefficient y. And the last group belongs to the constant term. The second step is to exclude the constant term by transposing it to the right side of the equation. In this case, we apply addition property of equality. Hence, we will have the quantity of x squared minus 6x plus the quantity of y squared minus 2y equals positive 15. The third step is to add a term to the binomials in order to make the binomials a perfect square trinomial. And that term is the square of b over 2, where b is the numerical coefficient of the linear term of the binomial. Do not forget to add the same quantity to the right side of the equation in order to maintain equality. Whatever you add to the left side should also be the same at the right side of the equation. In x squared minus 6x, the coefficient of the linear term is negative 6. Dividing it by 2, we will have negative 3. Squaring negative 3, the term to be added is 9 in order to make the polynomial a perfect square trinomial. Doing the same thing to the second group, we will have negative 2 divided by 2 raised to the second power. The result is 1. If we added 9 and 1 to the left side, we should also add 9 and 1 to the right side in order to maintain equality. The last step is to factor out the perfect square trinomials. X squared minus 6x plus 9 is equal to the square of x minus 3. Take note that 9 is just the square of 3. The second group, which is y squared minus 2y plus 1, can be factored out to the square of y minus 1. Remember that the square of 1 is 1. At the right side, we simplify 15 plus 9 plus 1, we will get 25, which is just 5 squared. Hence, writing the equation in standard form, the resulting equation will be the square of x minus 3 plus the square of y minus 1 equals 5 squared, or the square of x minus 3 plus the square of y minus 1 equals 25. What is the purpose of studying about circles? In order to find out, let's try this. What is the area of coverage of the given router in square meters if the boundary of the area of coverage of this router is given by the equation x squared plus y squared minus 4x plus 6y minus 2,487 equals 0. Estimate your answer to the nearest hundredth. To solve the given problem, we identify the geometric figure that can be used in order to model the given situation in the problem. We are given an equation having x squared and y squared. That means that the geometric figure which we can use in order to solve the problem is a circle. We are also asked to find for the area of coverage, which means that we are going to get the area of a circle. Remember that to get the area of a circle, we have the formula A equals pi r squared. We are only given the equation of the boundary. In that case, we have to find the length of the radius. The equation x squared plus y squared minus 4x plus 6y minus 2,487 equals 0 is an equation of a circle in general form. In that case, we have to write the equation in standard form in order to determine the length of the radius. We recall the acronym that we can use in writing the equation in standard form. We have DEF, D for determine, E for exclude, A for add, F for factor out. D. Let's determine the variables or the terms having the same variables. So what we did is to group the terms having the variable x, which are x squared and negative 4x. The second group are the terms having y as the variable. So we have y squared plus 6y. And the last is the constant term minus 2,487. The next step is to include the constant term by transposing it to the right side. So from negative 2,487, transposing it to the right will become positive 2,487. The next step is to make the binomials a perfect square trinomial. So we get the coefficient of the linear term minus 4x. So negative 4 divided by 2 is 2. Square that, we will have 4. So the trinomial will be x squared minus 4x plus 4. On the other group, which belongs to or which are the terms having variable y, we consider the coefficient of the linear term 6y. 6 divided by 2 is 3. Squaring that, we will have 9. So the trinomial will become y squared plus 6y plus 9. Remember that to maintain equality, whatever we add to the left side should also be added to the right side. So we added 4 and 9 to the left. We should also add 4 and 9 to the right, making that 2,487 plus 4 plus 9. The last step is to factor out and simplify the equation. The factors of x squared minus 4x plus 4 is the square of x minus 2, while the factored form of x squared plus 6y plus 9 is the square of y plus 3. Simplifying the constant terms at the right, it will become 2,500. Getting the square root of 2,500, we will have 50. So in other words, 2,500 is equal to 50 squared. We recall the standard form of the equation of the circle, which is the square of x minus h and the square plus the square of y minus k equals r squared, where h and k are the coordinates of the center and r is the length of the radius. So in the given equation, the square of x minus 2 plus the square of y plus 3 equals 50 squared, r is equal to 50. Substituting the value of r to the formula a equals pi r squared, we will have a equals pi times the square of 50. Substituting the value of pi and estimating it to the nearest hundredth, The area of coverage will be 7,853.98 square meters, or 7,853 and 98 hundredths square meters. Are there questions? If there are, you can send me a personal message through Messenger. Thank you for staying with me until the last slide of my presentation. In the next succeeding activity, I hope you will be able to apply all the things that you have learned in this video. After this video, you will be directed to a series of activities in order to prepare you for the summative assessment to be given next week. Thank you and have fun studying the circle.